Hi and welcome to my channel High School Physics. This channel is designed to make high school physics easy. In today's video, I'm going to talk about series and parallel capacitor. So let's get started. So I'll be starting with series capacitor. Series capacitor, let us consider two capacitors that are connected in this fashion. That is, the end terminal of one capacitor is connected to the starting terminal of another capacitor. So this is my capacitor 1, capacitor 2, and it is connected across a DC supply. The voltage of the DC supply, let us label it as V. And because it is a series connection, we know that the voltage is going to get distributed as V1 and V2. And because of the voltage, the current starts flowing in the circuit. So in series connection, current will remain the same. It's only the voltage that gets distributed. And because the capacitors store charge, so we indicate the current in the form of charge. So the charge on capacitor 1 will be Q. The charge on capacitor 2 will also be Q because current is going to be constant throughout. So now looking at the circuit diagram, we can write V is equal to V1 plus V2. I call this as equation 1. But we know that C is equal to Q over V. If you're wondering how C is equal to Q over V and then what is a capacitor and all that, please check out my previous video on what is a capacitor. There I have explained completely how this expression is obtained and what is the relationship between Q and V for C. All that is explained. So don't forget to check my previous video. So C is equal to Q over V. And here we are looking at V. So hence, we try to use V is equal to Q over C. So V is made as the subject. Now look at the circuit diagram. Across the capacitor C1, we have V1 and the charge is Q. So therefore, I can write this as V1 is equal to Q over C1. Similarly, I have V2 is equal to Q over C2. So I label all this as equation number 2. Substituting two into 1. So we get Q over C is equal to Q over C1 plus Q over C2. So Q over C is equal to, if I take Q as a common factor, I get 1 over C1 plus 1 over C2. Q and Q gets cancelled, and hence we have 1 over C is equal to 1 over C1 plus 1 over C2. So this will be the expression for series capacitor. So let's look at parallel capacitor. So if we have capacitor, two capacitors that are having common start terminal and common end terminal that are connected to the supply voltage. Let us label the two capacitors as C1, C2, and this is the voltage supply V. We know in parallel connection that voltage is going to be constant throughout. It's only the current that gets branched. So because of the voltage source, we have current over here. As I stated, even in the series capacitor, instead of calling it as current, we call it as charge because the charge is getting stored on the capacitor, but the function is the same. So we have the current that is getting distributed in the parallel circuit. So here I call it as the charge. Instead of current, I'll call it as charge. So we have Q1 and Q2 that appears across C1 and C2. Now from the circuit diagram, we can write Q is equal to Q1 plus Q2, because if I try to erase this and label this as Q, so it's Q1 plus Q2. Now, what is Q? Again, we know that C is equal to Q over V, or Q is equal to CV. What is Q1? Q1 is this Q1 over here that is appearing in C1. So we have C1, but the voltage that is appearing across C1 is V. So we write V over here. Similarly, we have Q2 is equal to C2V. So I call all these as equation number 2, and let us label this as equation 1. Now let us substituting 2 into 1. So we get CV is equal to C1V plus C2V. CV is equal to, if you take V as a common factor, we get C1 plus C2, and V gets cancelled. Hence, we have C is equal to C1 plus C2. So this is the expression for parallel capacitors. So I hope you understood series and parallel capacitor. So please don't forget to subscribe my channel for other topics in physics. So next post will be on capacitor charging and discharging, and there I'll be explaining about the current versus time graph when the capacitor is charging and discharging. Similarly, I will also be explaining the voltage versus time graph, and I will explain about the expressions for charging and discharging in that post. So don't miss out that video. And if you like my videos, please press the like button, subscribe to my channel, and share the video with your friends. And don't forget to click the bell icon so that you get notified as and when I post the videos. Thank you for watching. See you in the next video. Take care. Bye.